Starship, which is SpaceX's Starship spacecraft and Super Heavy rocket, represent a totally reusable system of transportation which is designed to carry a crew and/or cargo to Earth's orbit, to the Moon, to Mars and further. Starship is the world's most powerful launch vehicle developed as of yet and is capable of carrying up to 150 metric tons in a fully reusable configuration and 250 metric tons in an expendable configuration. Starship is designed to be a fully reusable spacecraft and second stage of the Starship system. The vehicle comes in several different configurations, one of which offers an integrated payload section and is also capable of carrying a crew and cargo. Starship is also capable of port-to-port transport on Earth, making travel to anywhere on the planet in 1 hour or less a possible reality. As the most powerful rocket launch system to date, Starship has the capabilities of carrying 100 people into space on long-term, interplanetary missions. Starship is also capable of satellite delivery and deployment, with development of a moon base and port-to-port transportation in the near future. Starship will be able to use tankers for refueling in orbit. These tankers are essentially other Starship vehicles modified into fuel delivery vehicles. Refilling in orbit will allow Starship a load capacity of 100 tons to reach as far away as Mars. Reusable refuel stations such as these will have an immense impact on cost savings and longevity. Super Heavy is the first stage, called a booster, of the Starship launch system. Powered by 33 Raptor engines using extreme-cooled liquid methane and liquid oxygen, Super Heavy is fully reusable and will re-enter Earth's atmosphere to land back on a mission-designated launch pad. Super Heavy is the reusable first stage of the Starship Super Heavy lift launch vehicle, which it works in conjunction with the Starship's second stage. As a part of SpaceX's Mars colonization program, the booster evolved into its current design over the past decade. Production began in mid-2021, with the first flight being conducted on April 20, 2023, during SpaceX's first launch attempt of the Starship rocket. The booster is powered by 33 Raptor engines that use liquid oxygen and methane as a propellant source. After propelling the second stage towards orbit, it can return to its launch site pad, where it lands vertically and is caught by its launch tower, thus ensuring full reusability. Falcon 9 is a reusable, two-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of people and payloads into Earth orbit and further beyond. Falcon 9 is the world's first orbital-class reusable rocket. Reusability allows SpaceX to reuse the most expensive parts of the rocket, which also keeps the cost of future space missions much lower. Falcon 9's first stage incorporates 9 Merlin engines and aluminum lithium alloy tanks containing liquid oxygen and rocket-grade kerosene propellant. Falcon 9 generates more than 1.7 million pounds of thrust. The interstage is a composite structure that connects the first and second stages, and also houses the pneumatic pushing mechanisms that accomplish the first and second stage separation during flight. Falcon 9 is equipped with 4 hypersonic grid fins positioned at the base of the interstage. They orient the rocket during re-entry by moving the center of pressure. While the fins are relatively small at around just 4 feet by 5 feet, they can control the roll, pitch, and yaw of the booster stage up to 20 degrees in order to acquire a precise landing. The second stage is powered by a single Merlin vacuum engine and delivers the Falcon 9's payload to the desired orbit. Made of a carbon composite material, the fairing protects satellites and possibly other cargo on their way to orbit. The fairing is jettisoned around 3 minutes into the flight and is recovered to be reused on future missions. Falcon Heavy is composed of 3 reusable Falcon 9 9-engine cores whose 27 Merlin engines together generate more than 5 million pounds of thrust at liftoff, which is equal to approximately 18 747 jetliner aircrafts. 3 cores make up the first stage of Falcon Heavy. The side cores, or boosters, are connected on the nosecone, the interstage, and on an octaweb. Shortly after liftoff, the center core engines are throttled down. After the side cores separate, the center core engines throttle back up to full thrust. Falcon Heavy is equipped with 12 hypersonic grid fins, 4 on each booster, positioned at the base and nose cone, which orients by moving the center of pressure during re-entry. Falcon Heavy uses similar Falcon 9's proven design to minimize stage separation issues and maximizes reliability. The second-stage Merlin vacuum engine delivers the rocket's payload to orbit after the main engines cut off and the first-stage cores separate and return to their landing pad. The Dragon spacecraft is capable of carrying up to 7 crew members out into and back into Earth orbit and to other space destinations such as the Moon or Mars. It is the only spacecraft currently flying that is capable of returning with large amounts of cargo back to Earth to date. It is the first private spacecraft to take humans to the space station. Dragon's trunk not only carries unpressurized cargo but also supports the spacecraft during ascent. The lower part of the trunk is covered in deployable solar panels that provide power to Dragon during flight and while on station. The trunk remains attached to Dragon until shortly before re-entry into Earth's atmosphere, at which point it separates. The Dragon spacecraft is equipped with 2 drogue parachutes to stabilize the spacecraft following re-entry and 4 main parachutes to further decelerate the spacecraft prior to landing. SpaceX company has developed 4 families of rocket engines: Merlin, Kestrel, Draco and Super Draco, and since 2016 developed the Raptor methane rocket engine and after 2020, a line of Methalox thrusters. The SpaceX Raptor 3 engine has 2.75 million newtons of thrust and the Raptor 2 has 2.26 million newtons of thrust. 33 Raptor 3 engines would provide 90.75 million newtons of thrust on a 33-engine Super Heavy booster configuration. The Saturn V had 34.5 million newtons of thrust. Starship will be powered by 6 engines, 3 Raptor engines, and 3 Raptor vacuum engines, which are designed for use in the vacuum of space. Super Heavy will be powered by 33 Raptor engines, with 13 in the center and the remaining 20 around the perimeter of the booster's rear end. Dracos are used as reaction control system thrusters on the Dragon spacecraft and the Falcon 9 launch vehicle second stage. The Merlin 1C engine for the Falcon 9 first stage is nearly identical to the variant used for the Falcon 1, although the turbopump exhaust assembly is not movable. A Merlin 1C vacuum variant is used on the Falcon 9 second stage. This engine differs from the Falcon 9 first stage variant in that it uses a larger exhaust nozzle optimized for vacuum operation and can be throttled between 60 to 100% with an increased thrust of about 90,000 pound force at sea level. I want to thank you for watching and I hope you found this to be informative. Please show me some support by pressing the thumbs up button and also the subscribe button. As always, it's totally free to you and helps motivate me to make more videos for your pleasure.